Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. Now see the question, it is saying that construct a minimal DFA. You have to construct a minimal DFA which contains set of all string over a comma b. So your string containing from symbols a comma b where number of a in W that should be 2. So number of a should be equal to, here the restriction is that number of a should be 2. So this language, so here sigma is a comma b and the language is containing set of all string where number of a should be 2 and rest anything, so like a number of a. So if silent not belongs to this language because number of a there is 0. Single a not belongs to this language because single a only one a is there, na? Number of a is 1, so it not belongs to that language. If I write a b a belongs to this language because number of a is 2. Now bb a fine belongs to this language. B any number of b, but still it is having 2a. Fine. Now any number of b, then a, then again any number of b, a, fine, belongs to this language. Here our main concern is that number of a should be 2. Irrespective of whatever number of b we are having, because the restriction here is that should be number of a in this string should be equal to 2. Okay, so like a, then after any number of b, okay, like this. So now construct a initial state q0. Now with respect to this language, what that state is indicating? Now that state is indicating that the number of a here is 0. Number of a here is 0. Now by getting a, number of a is now 1. Now I have told you that since it is a DFA, for every state we have to give transaction for every input alphabet. Q0 by getting a, I have given the transaction, it is going Q1. But Q0 by getting b, where it is going? Okay, so it will be in same state. Why? Because after getting any number of b, number of a is still is 0. Okay, so any number of b, number of a is 0. Any number of b, number of a is 0. Now by getting single a, now number of a will become 1. Now after that also if I am getting any number of b, fine, it will be here only. With respect to b, with respect to a, I am just counting number of a. So before first a, I can have any number of b. After first a, I can have any number of b. Then we can get another b. Now if you are getting another a, number of a is now 2. See, number of a is now 2. You will accept it. So you will make this as the final step. Now after reaching here, if you are again getting any number of b, fine. It will be here because number of a is still going to remain 2. But after this, if you will again get a, number of a will become 3. So now you have to go to dead state, that the condition get violated. There is no chance it will ever get accepted. So now by getting a, it should go to dead state. Now since it is a DFA, for every state we have to give a transaction. After reaching dead state, if I get again a comma b, it should remain in the same state. So for Q0 I have given the transaction of AB, Q1 also done, Q2 also done, dead state also done. So what is the number of states you require for this minimal DFA? You require 4 states.